All right, welcome and thanks to all of you who turniped. My name's Nate Handy. This is a little bit about me. Yes, I am a man. I am currently employed at Bluehost, of which is there's quite a large percentage of the audience here who is Bluehost. At this point, I'm sure you've heard this almost at every presentation, so I'm going to say it a little bit differently. I am not being mandated to tell you that as an organization, we are seeking Perl wizards to embark on a quest of a programmatic nature in parties of varying skills and powers, with the end goal being to level up our features and to ultimately vanquish the evil productionist buggetus. Oh, and there's epic loot involved. So anyway, I enjoy working for Bluehost. We have a really good team that I work on right now, and it's a lot of fun. So a little bit of my background, I've spent a lot of time in databases, BI work, as well as just varying databases, everything from smaller databases to large-scale production environments or enterprise environments. I have been working with Perl. I've taken breaks from time to time at different jobs, but I always seem to be coming back to Perl. I currently have 4 kids, and 2 of them are teenagers. One's a tween. Raising 2 teenagers, it's not a piece of cake, and as most of you know, the cake is a lie. So I'm a dad, which is a parent. So this is where we talk about what's acceptable, and groans are completely acceptable responses to this talk. So I get plenty of those from my teenagers. Eye rolls are also acceptable. Face palms, especially Picard level face palms, are definitely acceptable. I ask that you do not throw anything unless, and here's a couple caveats, that it is a non-perishable food that is still contained in its original packaging. Uneaten pastries are also acceptable. And money, I will always accept money thrown at me. So, speaking of dads, my dad, he is just like a father to me. No, really, he even married my mother. With Father's Day having just happened, I want to share a little story about my dad. And a long time ago, in a country far, far away, Germany specifically, my dad was living there, and he got invited over to dinner with his roommate. And when they arrived at the location, the smells permeating from the kitchen were just overwhelming, and this is what he smelled. Beautiful roast. Just he was salivating like no other. He's like, oh, this is going to be so great. This is what he saw in his mind. So the host brought out the food under a silver tray, a silver cover, placed it on and lifted it off. Now, before we get to what he saw, I want to talk about something, and that is fat content in roasts. So as you talk about roasts, you go with kind of a leaner cut, a sirloin cut. You get about 7 to 10% fat content. It's a little not quite as flavorful as maybe a round roast, which you get up to 10 to 15%. Go up to a chuck, which is a really nice, flavorful roast, especially cook it a long time and get that fat to break down. So, and then you talk about like ground meat. You can go from really lean, like a 2%, all the way to 30%, which is like a third of your, burger. If you're making a burger on the grill, is just going to melt off as you're cooking it, and it makes for a really flavorful So one thing that my dad didn't anticipate with the smell was that his roast looked like this. It had 95% fat. I couldn't find an image that would fully represent this, so I did a faithful recreation of it. That was the meat there. The rest was fat. He saw it and thought, okay, well, there's a little bit of fat. I'm gonna, we'll have a little bit of meat. We'll have a little bit to eat there. His host proceeded to carve off the meat and place it in front of her plate because she prized the fat as the prime cut of the meat. She proceeded to cut into cubes about an inch in cubic nature and plomp on about 10 of them onto each of their plates. My dad looked at this and, well, this is essentially what he saw there. Just these big globs of fat that weren't quite cooked all the way. And if you've had fat that hasn't been cooked all the way, it's not pleasant. He said it was like tasting rubber. So anyway, he tried to chew through these, and it just was not breaking down. So he decided to just go ahead and eat them like a pill. And so he threw a bunch in his mouth and just took a huge gulp of water, swallowed them all down. Well, the host took this as he was really enjoying them. And so she piled on quite a few more. And at this point, my dad said, I really can't do it anymore. So he was looking for a way out because he didn't want to be rude. And he turned and looked and saw this. He saw a window, and he thought, okay, this is perfect. I'm out of water. Let me ask for some more water. And while she's gone, I'll go ahead and, just toss them out. So as she left the room to go get a refill, he grabbed a handful and he threw them at the window. This is where we talk about the amazing product that Windex is. So Windex is an amazing product. It can make seem like windows aren't really there. And that's what my dad didn't really sense, was that there wasn't an open window. There was a closed window. And when the fat splattered against the wall, his roommate proceeded to roll on the floor laughing because of the situation. So he got his roommate to get up, go and distract their host, scooped up the fat, opened the window, tossed it out, kind of fluffed the drapes to make sure that it didn't appear like it was there, and then quickly made their goodbyes. Not the proudest moment, I would say, but it makes for a great story. So why did I tell this? I would say that what we can learn from that story is, it's best not to assume. You don't assume that you know everything going into a situation, and it's best to analyze that. So what I want to talk about now is recipes. I love to cook. I love to I do kind of all forms of cooking. The latest I've gotten a sous vide machine, and it's been great, super tender. But I like to do my own stuff, but occasionally I do like to look up recipes, gather intel on them, but I have a few gripes about them. So my recipe gripes are, when I look up a recipe, is I don't need your life story. I don't need to know how it changed your life, this one recipe. I really don't like reading paragraphs of text through and through. Just get to the point. What am I doing? And, recipes as they stand aren't very visual. They don't kind of jump out to you as what it is you're going a path to go. And so I went to a talk a few years ago at the local the open source conference here, and someone was presenting on MongoDB, and they shared some interesting information about it, and I was very intrigued. So the individual shared something like this and said, okay, this is what MongoDB storage looks like. We've got this, what they call a document, shows a data structure that looks a lot like JSON, and that you've got nested structure. And the first thing I thought when I saw this was, wow, that looks like a recipe. Well, maybe it's not perfectly obvious to everyone, so let me explain my reasoning. Here we have a bunch of different containers. You've got different ingredients. And what is a recipe more than manipulating each container, placing it in, combining with other containers into a bigger container, and so on and so forth until they're all combined in one container in the end. So to me, that looks like a nested structure that flows up from the very deepest level. So before we get into how I structured this a little bit, let's go over some quick MongoDB basics just as I reference them. So just kind of versus your standard relational SQL terminology. So you've got a collection, which typically is a table, document, which equals kind of a record or a row, and then those are broken out where you typically have your column. You have your key and you have your value. So going back to there, you've got this is a document here. The name would be a key, and then Joe is the value, and so on and so forth, and they can be nested through. So I set up a quick MySQL structure just to essentially get to where I would like to be with the output of my database to be consumed by the front end. So I've got a recipe, I've got steps, which kind of can contain other steps, got ingredients, which are included in each particular step, and then I've got the actual ingredients and their names linked to each step. At this point, talk about what with the MongoDB structure. One of the cool things about MongoDB is you don't need to necessarily have the structure set up beforehand. You can just supply it to it, and it'll allow that structure to go through. Now, you can do validation and in strict make sure that there is validation on the structure on inserts and updates to make sure that you maintain integrity. But this is essentially what I came up with. So this would be the recipe for making a ham sandwich. So if we talk about at the very deepest level here, you've got your ingredients, which are bread and mayo. The action is go ahead and spread mayo on the bread, and then go up one level further, and then you place the ham and cheese between the bread. Go up one level further, because I really like cheese. I'm going to add more cheese, and so on and so forth. So that's kind of the structure, is this nested approach. Have listed out all the ingredients that are associated with it as well. So visually, I had this kind of concept to go about it. So this would be the deepest level of it. So in this case, I am making some cheesy grits. So the first thing I do is I take some water and some salt and boil it. The next step, which it would kind of zoom out on, would be, oh, okay, we're going to take some cornmeal. Once it's boiled, you take some cornmeal, gradually whisk it in. From that point, you go ahead and reduce the temperature to low, stir until thickens, which is about roughly 15 to 20 minutes. At that point, you zoom back out and you take off the heat, and then you add in the Parmesan, the butter, the milk, parsley, and you stir until the cheese and butter are melted. At that point, you go ahead and season with salt and pepper, and you're done. So as you can see, this structure kind of goes from an inward all the way out approach, kind of a zoom out approach. So what were my MongoDB assumptions heading into this? Because I wanted to do this, but I was a little worried about a couple of things. One is, am I going to get it to a place where it's acceptable from a performance standpoint? Can I get it to where it performs like a relational database? How is the querying going to be? Because it seems like, coming from a relational table standpoint, I'm familiar with that. I know join in tables, how to do all that. What does the querying look like? So let's go ahead and move on to implementing this in Perl. There's a couple of great modules. Obviously, I just went ahead and used the default DBI for the MySQL piece. For the MongoDB, there's just a module called MongoDB, which makes the Perl implementation really easy. So let's go ahead and compare the two between what it looks like in Perl. Apparently my animations are awesome. There we go. Okay. So for the MySQL implementation, you go ahead and open a DBI connection. You pass in everything. Oh no, I forgot to take out my password. Sorry about that. For Mongo, you can set up a client, which is basically the database connection, and then like the collection was said, you can go ahead and specify a particular table. You can also make a direct call to MongoDB Mongo collection and just pass it the additional collection that you want to and get that. So you could do it in one line. I showed it as two to show the distinction. So on inserts, how do we go about doing inserts? So we can go ahead and do a basic DBH do, which is awesome, but probably or better would be actually preparing the statement and passing in bind variables, prevent SQL injection. And so for the MongoDB, it's kind of nice. You don't really have that whole SQL injection piece. You've got this data structure, as you can see. I've just got a hash with one element called name, naming it burnt toast. And at this point, you're not really worried about the SQL injection. I guess the only case would be is if you, as part of your program, were actually iterating over these values and maybe doing system calls on them, which I'd highly suggest you don't, against data that isn't validated. Anyway, so insert, it's pretty straightforward. Okay, well, what about querying? I was a little bit worried about this. So I've got my query statement. I want to grab from recipe where the name's like toast. That's pretty straightforward, and we pull out the values in a hash ref. So in Mongo, how do we do that? Well, you build it just like the structure that you have. So I have name as an element, and then you can go ahead and pass in a regular expression. So in this case, I just want to grab where it's like toast and not case sensitive. And then from that data object, you go ahead and just grab the next one, which is just like a fetch row. So that's actually pretty easy at this point. So it's time to test. I would like to say at this point that I went ahead and used this, but I'll be honest, I didn't learn about this until Monday when David gave that great talk on higher order functions. This is a really good talk. You should go back and see it if you didn't. Data fake, really good for making fake data. I wanted to create fake data and make it plausible. So I set up some rules for me. This is the module that I created. Basically, I picked at random a protein, a veggie, 2 spices, and an action. I figured with that, I could create a fake recipe that sounded pretty good. And so with that, I went ahead and generated 100,000 fake recipes, went ahead and inserted them both into MySQL and into MongoDB. And the results were really interesting, actually. So in fact, I liked them so much, I took the next logical step that any person would do, and I'm starting a restaurant. As you can see, these are some very interesting recipes that my generator came up with. I think my favorite is the roasted sea pork with guajillo tomatillo. Anyway, it was lots of fun, and I realized that playing with random data can be lots of fun and waste a lot of your time just looking at these. So anyway, this was the real fun part of my experiment. So let's go ahead and catch up on the actual testing that we're doing here. So what I wanted to do was I inserted around 100,000 recipes, and these were the test scenarios. They weren't super comprehensive, but I wanted to just count based on the name. So I did that similar query to what I did before, which was grab one of the ingredients and say, oh, how many recipes had this ingredient in the name? I also did a count based on one ingredient. So I searched the particular ingredient and said, how many recipes contain this ingredient? A little bit different because of the structure, but essentially the same. Then I also did details, so I pulled out the entire recipe, including in MySQL, I converted it from just a bunch of rows, which would have been like 5-6 rows, to the actual data, the nested data structure that it looks like. Because my end goal would be to hand this off to a front end that could display like I showed before. So the full recipe with parsing to JSON. So I decided to run this 100 times through this scenario and timed it. And what I found was kind of interesting and a little bit different than what I expected. So and as a caveat, both these databases were strictly not touched from an optimization standpoint. I just went ahead and created them and added the data to it. So with the optimization, results may vary, I guess. The count based on the name of the recipe, MySQL was, quite a bit faster for that. The count based on one ingredient, though, Mongo blew it away. MySQL almost took twice as much time to come back with that. And that really, I think, points to the fact that Mongo really handles data structures that are complex a lot better than a relational table database would. The details based on the 2 ingredients, MongoDB was a lot faster still. I included the details because I wanted to see the time it took for the conversion of the actual data, but turns out Perl's pretty awesome at converting data structures, and although it was kind of a pain to write, the actual conversion from MySQL rows to a hash took milliseconds to the, tens of seconds of the querying, and so it was negligible. So in the end, what did I learn out of all of this? So MongoDB wasn't up to my assumptions. It's not that hard to set up and learn. I was able to just go ahead and do a quick install of Mongo. I was up and running in just a couple of minutes. doing a cpan install on Mongo. Got set up immediately, and the interface with the Mongo database was actually really nice. It was better than I expected. It was actually pretty quick, and it really handled the complex-ish data structure that I worked with, albeit wasn't super complex, but it was complex enough to show kind of its strengths for that. I also learned that randomness can be actually quite fun, and it's fun to just explore things. And I think one of the things that we take for granted sometimes as programmers is finding fun in the work that we do, making something enjoyable so that that we want to continue to work. The other thing is maybe I should search on cpan before I start to build something, data fake. And if you have a project in mind, getting it accepted for a conference is great motivation for working on it. I had this idea for a couple of years and just didn't really get around to it. Talked about it with a coworker, and he said, hey, you should submit it for a talk at TPC. And so I did, and got accepted, and so that was my motivating factor. And presenting at TPC has been a serial experience, and I thank you all for coming. Are there any questions about, yes?
When doing the setup on MongoDB, was there any problems with it that you had, like any, on the Linux world with failed dependencies, that type of thing, or with cpan, again, with the dependencies?
Yeah, cpan did have to install a couple of dependencies, but it handled it just fine. Literally the MongoDB cpan module took maybe a minute to install. MongoDB itself ran. I just had to run in a separate terminal, the MongoDB, and then I was able to command line to it instantly. There was no issues connecting localhost or anything like that. So.
Did you use Windows or Linux?
No, I used my Mac, so that was my experience with it. So, yeah.
Can you put your MySQL schema back up on the screen?
Yes, I'll keep going back. There.
So your count, you counted by the name, what tables were you querying?
Just the recipe, yeah. So, and that's probably why it was faster, just from the standpoint of you had maybe the 3 data elements versus the whole structure within Mongo. That would be my guess towards that. Yeah.
Is it also possible to sort, because doing the search in the one ingredient case was evaluating an RE?
Well, technically they were both doing that, right? You were doing a like, and in MySQL it was both it was case insensitive as well. I would think that it would be pretty much the same. So, yeah.
For the ingredient searches, did you index on the name?
Right, like I said, I didn't index anything at this point. I was planning to go that route and kind of show that, but yeah, I just ran out of time.
It's a little unfair to do the performance comparison for MongoDB.
I realize that. I'm not, the point of this wasn't necessarily to say Mongo is so amazing and it's so much better than MySQL. The point was, hey, Mongo seems to be able to hold its own, especially when talking about complex data structures. I have no ball in the fight. I mean, I use MySQL every day and will continue to use MySQL every day, but it has opened my eyes to using a document storage like Mongo for especially complex structures. Yeah.
Do you use indexes on anything on Mongo?
Yes, there is indexes that you can create on Mongo. Yeah.
They're actually quite complex indexes. You can index over arrays and full text in
The question was, why did I think that Mongo was possibly going to be slower? And the reasons for that were a couple. The table, being able to pull in just the data that you needed versus having the whole document there, as well as the whole nested, be able to query within the nesting, was something that I was unsure of how Mongo would handle. And so it mostly comes down to just lack of familiarity as to why I made that assumption.
I might have missed this, but what did the process you used to determine the speed? How did you benchmark it?
I used a couple of things. I was having some issues with how it was determined. I was using NYT-prof for some of it, but based on how I wrote my code, it wasn't completely clear how that was. So in the end, I just ended up running through these iterations just by timing them with high res. So.
Now, did you try scaling it? Like, okay, you have 100 recipes, then you have 1,000, 5,000, 10,000 to see a performance where you start seeing differences, or was it just the one run with 10 recipes?
It was basically the one run. Yeah, I didn't have the time to scale it up. All right. I didn't look at that actually, so that would be good to note. Yeah.
Just, hi, I'm David. I wanted to say, because there are a lot of questions coming up about performance, and not to discount anything of this like quick experiment. When I talk to people in our support department, 90% of the questions that people have, the answer is put an index on your query. So whether it's MySQL or Postgres or MongoDB, knowing what your queries are and getting indexes on the important high-point queries is absolutely essential to performance.
Yeah.
So,
Agreed.
questions of performance are sort of moot unless you actually figure out the right indexes.
Yeah. Yeah, Mark.
What version of the Mongo drivers do you use?
Whatever is the latest that was on
So do
CPN.
you have a higher Perl installed on your local machine?
I don't.
There's a limitation of version .31 or something that you couldn't go above if you didn't have a, we ran into this a few years ago when we were stuck on .6. Couldn't install the latest drivers. Does that sound familiar?
No. I.
Versus the version 10 or something?
So, yeah. All right. Well, thank you so much for being here, and enjoy the rest of DPC.